Hello and welcome back to DriveDriverDriven. I'm Humble and we're back again on the Blunicorn project. This time we're diving headlong into wiring, not just on the chassis, but with the motorsport aim stuff and on the engine as well. Like any good cooking show, I've sort of prepared my ingredients ahead of time, so let me show you where I'm at and what I've been up to. Basically, it's a mess. Let's start up here actually. So I have my replacement battery in. This is an Odyssey PC1100, which is what the Ultima comes with from the factory, and worked well for me, except for during the fire in the shorts, and my old one unfortunately perished when the case cracked and it dumped all its electrolyte out. If we go over here, let's start with sort of our chassis side. So this go around, I have a Motec PDM 30 instead of the Ultima wiring harness. And for those that don't know, this PDM, or power distribution module, basically replaces all of your fuses and relays, and it allows you to not only data log and capture sort of power performance of the different devices that are plugged into it, but in like a racing environment, you can also shut off or reset or retry different devices that may be failing or drawing too much current. And that's for stuff that may be race ending and you can get by with a couple of resets. So stuff like this is super handy. I wanted to switch to that for my car, just to simplify the wiring and to be able to control and monitor things a little bit tighter than the factory switches allow you to do. Moving up top, to go with the PDM 30, I have a 2x4 CAN button pad in a recessed sort of mount. These are nice because, again, instead of a whole bunch of switches and wiring, it cuts it down to 4. So you have your CAN wires, your power and ground, and that's it. And that allows you to run not technically 8 switches, but because of how you can configure these in the management software, each switch can actually be 3 toggles. So you'll have maybe off, low, medium, and high, or you can have on or off, or you can turn it on with one button press, or if it's having an issue and one of these lights lights up, you can press and hold it to reset the circuit, or a quick press to push it off. So the software allows you to do many, many things with just a single button, much less multiple button presses. This is the Raptor wireless steering wheel buttons. And let's see, currently it is trapped under my wiring. Okay, so this is the old box. I believe this is a Gen 2. This is what the Ultima ships with. And this is supplied by Ultima. This is the old box, and these are the old buttons. If you look at the back, they have these sort of protrusions out the back. The buttons themselves protrude a bit further out the front, plastic caps, etc. This setup worked very, very well, except an early sort of decision that Raptor made with this system is that it constantly talked back and forth between the steering wheel and the receiver box, even when it wasn't needed. And as a result, the battery that sits under here would drain in the span of 2 weeks or less. You constantly had to replace those batteries. Another option was to direct wired into like a horn circuit or a separate circuit. So it would just be fed 12 volts all the time, but only while the steering wheel was connected. With the new system, which is, this is a bit of an upgrade. So this is the Raptor GP, which is a sort of a racing version. Still the same technology, wireless, blah, blah, blah. But this guy allows you to do a drop 5 volt output instead of a 12 volt. And it has a couple other options for the race version versus like a street version. And these are the new buttons. So you can see sort of back to back the upgraded buttons. These are really, really nice. They don't protrude out the back anymore. They're just a surface mount. They're closed in with a membrane, so they're a little more water resistant. That's important for you open top guys that might see some weather and get rained on a bit. This is much less susceptible to the elements. And then same thing again. You have the same controller, same battery underneath, except now the cap, instead of a twist lock, is held on with nice little magnets. And I chatted with Lee from Summit Tech for a little bit over the phone, and he filled me in on a lot of these updates. And the PCB on the newer version is thicker. It no longer transmits back and forth constantly. It only transmits when you hold the buttons down. And as a result, basically the battery lasts, well, as long as the battery lasts. It doesn't run out prematurely. It's just the lifetime of the battery. So you won't have to be swapping these out constantly every 2 weeks like I had to previously. I really, really did love this system. I've used other like steering wheel buttons in the past that with the wire and everything that gets tangled up, and I really, really like the freedom that this has without the hang-ups. And I can't recommend these highly enough. Also, Lee's just a totally stand-up guy, awesome dude, and I really appreciate the time that he took to cover all of these new updates with these newer systems. So this isn't just a motorsport one. All the newer systems are running these style of membrane buttons. And they have a this particular setup for like Ultima, where you can either have the buttons in black or, you know, colored like this. There's a button sheet that they include that has you know, different symbols if you want to have different functions, because at the end of the day, these are just 8 buttons, and as you feed them into either your wiring loom or your PDM, they can do whatever function you want them to do. But in this case, I just stuck with the Ultima purposes because I found that worked really well with the steering wheel control. So again, can't speak highly enough of Summit and their wireless steering wheel products. Highly, highly recommend. Moving on from there, we have another Summit product, which is really simple, actually. It's just a little warning light system. I had this same system in the car before, and all it is it's just a row of LEDs for warning lights. So your turn signals, your high beams, oil and charge light, etc. It's all nice in this compact unit, and super easy to set up, wire in, and install. Key and wiring. So the way I'm doing my key this go around is this is going to be the master switch for the entire car, and that doesn't really sound out of the ordinary, but the way this will function is it's going to be a ground switch for high power relays that provide power to the rest of the systems in the car. And while it's not a true power isolation, I have an actual battery cutoff switch, which not only isolates the battery, but it has provisions to disable the alternator as well, which is important for any cars that you truly want to isolate and turn off in an emergency. But what this will do is, since I'm going to use it to energize relays via a ground loop or a ground connection, is those relays will provide power to all of the high power systems. So that's going to be my AC, my ECU for the engine, my PDM, and my power steering motor as well. And then, because it'll basically turn off all of those items, it will successfully turn off the engine from a running situation because we've pulled power from the ECU. So I really like having this on top of power disconnect that I can run to the outside of the car. Speaking of power steering, so that is this guy here as I unbury it. So this is the controller. So this is a DCE power steering. This is the sort of the monster end of the scale. This is their motorsport and autonomous driving unit. It is way overkill for what's needed for this car. As I mentioned before, though, this was a gift, so I'm going to use it, and I've already run the mounts and everything for it. Basically, this guy outputs, I think it's 88 or 90 foot-pounds of torque worth of steering effort and assistance down to the wheels based on what your input is. There is a torque sensor down here below that will measure the load or input on the steering wheel side, and then using this motor, it gives additional assistance to this end of the steering. And that's sort of how these systems work. It draws a fair amount of power, which is what this controller is for, and I still need to hook up a steering angle sensor, which will help limit the assistance and power of this unit once it gets to the steering stops. Otherwise, if you keep trying to turn into the steering stop, what happens is it sees the load on this end and tries to push harder against the steering stop, and you burn out your controller. So you definitely want to have a steering angle controller on these types of systems. Sort of moving across the car now, I have my AIM dash. I had the AIM MXS, which is the smaller dash, previously, and that was the first generation. This is now the MXS 1.2, which, if I pull it out here, has a smaller CAN type connector for cameras, for both front and rear cameras. And that was something I sort of needed before, and I tried to make do without, but I ended up having a couple of close calls. So usually during parking is when that happens. So I'm going to run a front and rear camera with this guy, and it gets mounted in the same carbon binnacle as before, also provided by Ultima. And this is my GPS sensor for speed and position. So I really like this system, and the fact that it's also CAN based means that I can get sensor data from the ECU as well as from our PDM, and then display warnings based on those inputs. Again, moving across, our HVAC system, this will be powered by our same PDM for the blowers specifically. Our washer bottle's in the location it needs to be. Before I go to the other side of the car, I want to kind of come back here for a moment. So each side of the car has a fuel tank, but on the driver's side, not only do you have your internal pump here, but you also have your fuel sender, which is this guy here, and it's only on the driver's side. The passenger side is just for additional capacity. And the way I'm going to route my fuel system is my main pressure and fuel feed to the engine will come out of this tank, So it'll be pressure out into the fuel rail, where it'll go to the other side, out of the fuel rail and into the fuel pressure regulator, where there's going to be a pressure sensor, and that's where I'm going to set the pressure for the system. Then it returns to the offside tank, the passenger side tank, and then in the passenger tank there's another fuel pump, and that's going to pump fuel over here into the driver's side tank. There is also going to be a balance tube between the two tanks, so if there's any overflow or when you're filling the tanks, they can balance between them. And then there is a vent that will be joined together through both tanks, and if I can find one that'll fit in the space I have, I would like to also connect them to a charcoal canister and then into the intake. Engine electronics, nothing too fancy. It's a Holley Dominator setup, which is an upgrade from the E67 ECU I was running previously. I'm just going to say it's completely overkill for what I'm doing, since I'm not doing transmission control and I'm not doing turbo or forced induction. It is, however, a very good, very robust engine control system. So I've been sort of browbeaten into upgrading, and again, that was a gift, so I do want to use it and put that on the car this time around. An upgrade that I'm doing for this rebuild is I've installed EGTs, thanks to Spool and Phil on Instagram, who welded these up in very short order, and he did an awesome job. I cannot recommend him highly enough if you just need something done really quick. Totally cool guy, working on a number of awesome projects. So he managed to just pop these EGTs in for me, and so I'm running 8-channel EGT to another Holley controller for those, so we can do per cylinder trims and sort of thing for tuning, as well as catching some situations ahead of time before it damages the car. Something that's different with the Holley setup versus the E67, it doesn't have a provision for a mass airflow sensor, so I got this block-off plate, but it still can do drive-by-wire, so I have the same Nick Williams 104 throttle body that we're driving off that unit. And luckily, the harness that I have reaches all the way up to the front for the pedal. I think that's it for this side. We have our usual stuff in the back for wiring. Things like our tail lights, some additional oil temp sensors. This go around, I'm going to wire my clamshell warning system to the PDM as an input. That way I can have it do an ignition interrupt or kill the car if the clamshell is left unlocked, to help prevent a very expensive mistake. So I'm kind of looking forward to setting that up, or at least a full dash warning light or something like that, something that's hard to ignore. Actually, while I'm on the subject of power and we can see it, another upgrade to the car is I'm upgrading to this 370 amp MechMan alternator. I've mentioned it previously, but since I'm running so many power hungry systems now and pulling accessories off of the engine, I needed to upgrade to something that could not only provide a bunch of power, but do so down low in the RPMs. And not only that, but something that could tolerate racing RPMs and spinning very, very quickly. These alternators are a little bit on the pricey side, but it's a 370 amp alternator that also provides an adequate amount of current way down low in its RPM band. And that's important for like crawling through parking lots with your power steering and AC going. That way you're not running the battery flat. But it also tolerates spinning up to, you know, 8,000 RPM on the engine, and you're not going to wear the bearings out of it. Moving across to the front, more electrical. So the PDM is actually strong enough to drive these big fans. Each fan is its own 20 amp circuit, and while its initial power up is going to be higher than that, as it spins up and it comes up to speed, its power draw actually decreases to below that 20 amp threshold. And that's sort of an important difference between a PDM and a fused circuit that's traditionally set up. Is if I put a 20 amp fuse in this circuit, as they were originally, what happens is as soon as the motor draws more than 20 amps for a second or something like that, it blows the fuse and then the fan stops working and the car overheats in short order. Versus on a PDM, what you can do is set it up so that as the fan turns on, it may go higher than your 20 amp current allotment, but then as the fan speeds up, it draws less current, and then it'll settle into, let's say, 16 amps instead of 25 amps, which you would see initially. So you can set those kind of conditions in the PDM where it'll allow overcurrent for a few seconds and then settle back down under a 20 amp circuit. And you can still have it blow at 20 amps, air quotes, blow at 20 amps, if it sees more than 25 amps for 5 seconds or something like that. And you can even have it set to retry when it does blow. So that way your fans aren't actually inoperable. And this is kind of what I meant before by saying that you can have race-ending failures with a fuse and switch system versus the PDM, which will allow you to keep running. Also in the front, we have our lift system tucked back down under there. You can sort of see how tight things are getting now with the battery in place. There's just not a lot of room for stuff up here anymore. So I'm going to have to figure out a good location for our kill switch. This is our drive-by-wire throttle sender that goes down to the pedal. And the wire's just kind of loose right now. It's not really routed properly, but that's where it's going to live and route, is down through here. And then our wiper motor, when it's installed in the car, actually tucks down in this space here. And so that will also be wired up and driven from the PDM. Again, talking about funky circuit design, you'll have like a high and a low speed circuit plus a wiper park circuit, which is an input that feeds back into the PDM. All of that can be driven so you can provide multiple functions for your wiper engine or for your wiper motor. Things like high speed, low speed, intermittent. You can have different intermittent timings if you want, or to park the wipers in the correct location once you turn it off. Continuing on with our power feed and electrical system, the new AC unit, which will be powered from our high power relays. This is a nice design in that you have a high power feed, your ground, but then there's also a control circuit, which is a lower power circuit that's also 12 volts. So you can drive the low power circuit with a low voltage feed, and then all of your power comes from these larger leads. Over to our ECU. Again, as I mentioned before, I'm upgrading to the Dominator. This was sort of a rebuild gift from a friend back east. Huge thanks to Bob for providing this. Bob's an awesome guy. He's helped out many builders with Ultimas. We have sort of a used Ultima parts program between me and Bob and sending our various parts around. So sort of nice about the Ultima community is we all support each other. So shout out to Bob for sending this along, and I'm going to put it to good use. So this is our ECU. This is our EGT controller, which will also plug into this. And then this hot mess of wires is all of our motorsport sensors that survived the fire. So this is for our tire temperature sensors, our brake temperature sensors, additional coolant and oil temp sensors, and then a couple of upgrade replacements from Izzy Racing. This is how he's progressed with his part design. So this is the old temp sensor, and you know, kind of a big chunky unit, but it held up to track abuse. It did really well. And then now this is how big they are. Just tiny, cute, very small, easy to mount. I may end up grabbing 2 more of these just for the reduced footprint and the reduced size. Again, I can't speak highly enough of Caleb and Izzy Racing, just in the quality of parts and everything he's putting out. Keep it up, dude. You're doing awesome. And then that brings us back over to our passenger side tank with the in-tank pump and all the electrics for the engine and whatnot. So kind of a long explainer there, going all over the electrics, but there's a lot on the system that I wanted to kind of give a quick overview about. And once I get these systems hooked up and running, I can go a little bit more in depth into their functions, at least for some of the more fun ones, like the steering wheel buttons and the can pad and how I get those configured. But for now, I'm going to call that a day. I'll pick you guys up again next episode where I can show you some of those functions and hopefully get the car to a place where we can kick the starter. So until then, I'll see you guys next time.